Mwache Mombasa tukapite naye.
Niko na babangu huko Mombasa.
No, uko na babako Mombasa? Ninamaanisha mpenzi wako husband.
Banga sana mkisema ile kitu ni mzuri. Okay, remember I have been told the other low-level programming language is the assembly language. Assembly language. And we say assembly language, we saw it's a second generation programming language. So it's also called a low level. Why is it a low level?
Hello.
Designed to facilitate a human interaction with the computer hardware at the most fundamental level. So, assembly languages form a fundamental form of the foundation of low-level languages. They offer the bridge between the machine language and the high-level languages that are more readable to human. Then assembly languages are also architecture specific, platform specific. Assembly language HC.
BPH ndio seventy. Inamaanisha inachukua more than 600.
Uno bwana. Winjo gik ma ji timo.
Foto pemilihan.
Niambia tu footsteps zangu.
Ka video na post.
Anatokea. Can you mute your mic?
I was saying that I think the first week we started with the introduction. Now this is, I think this is the third week, but we are going now to look at the entire course. And I want to share my screen. Kindly mute so that you can hear me when I'm speaking. Kindly mute so that we can be on the same page. So last time I think we looked at these types of machines, the activities. So today I want to start so today we had already looked at the objectives of what a computer is, the introduction to computers, the evolution of computers, classification of computer, characteristics of computers, application of computers, and advantages and disadvantages of computers. So what you need to know that at the end of this topic, you should be able to define, just doing a recap, explain the evolution of computing technology and technological advancement in computer architecture to current technologies, then explain the characteristics of computers and how they are different from the humans, then explain the different types of computer categories based on size, price, and capabilities. So we were able to do this. You were able even to define what a computer is, and we moved on. We were able to define what a computer is. Those who missed, we already defined a computer is. Then we are able to define what information data, the difference between data, information, and program. We were able to look at the evolution of computers, the abacus, the Jacquard automated loom, the differentiated engine, 1800s. Then we are able to look at the analytical engine. And then we looked at also the activities. Then we looked at the various computer generations. And here we have the first generation, which we talked about. They started from 1946 to 1956. And then the main features of the first generation, this is a recap. That's why I'm moving fast. They use the vacuum tube technology operating system, were very slow and reliable, supported machine language only, very costly, generated a lot of heat. They had very slow input and output, huge size, need of air conditioning, and unportable, and they consumed a lot of electricity. Then the examples were there, the NVAC and what. Then we have the second generation, where they used transistors, vacuum tubes, instead of vacuum tubes. So they used transistors instead of vacuum tubes. The use of transistors, that's in summary, reliable and compared to the first generation, smaller in size compared to the first generation, generates less heat as compared to the first generation computers, consumes less electricity as compared to the first generation computers, faster than the first generation computers, still very costly. Then the AC needed. So they supported the IBM 1620, the IBM 1794, the CDC 1604, the CDC 3600, the UNIVAC 1108. So those are the things, and we show that. Then now we look at the third generation. We look closer at the third generation. And here they use the ICs, more reliable, smaller in size, generate less heat, faster, lesser maintenance, and still costly. So the examples in that series, we are also able, so you look at the notes and again, recap on yourself. Then we looked at the fourth generation, very large scale integrated circuits, technology used, then very cheap, portable, and reliable. So PCs, very small size, pipeline processing, no air conditioning needed. Concept of internet was introduced. Then great development in the field of networks, computer became easily available. Some computers of this generation were the DEC, the Star, I think we talked about them. And I even asked you what distributed computing is, and you're able even to define. So we are now going to the fifth generation computers. And here we used ultra, very large scale integrated technology. development of true artificial intelligence, development of natural language processing, advancement in parallel processing, advancement in superconductor technology, more user-friendly interfaces with the multimedia features, availability of very powerful and compact computers at cheaper rates. Some computer types of this generation were the desktop, the laptop, the notebook, the ultrabook, the Chrome. So research shows that the trend in computer technology revolution is that there is continuous decrease in computer size, improved speed and power processing, decrease in computers, and the related facility costs. So this is what we looked at, and you were able to look at that. So you can also look at those questions and be able to answer them. Then the types of computers. So computer can also be classified according to generation, then classified according to functionality. So we have the analog, digital, and hybrid computers. And here, when we talk about analog computers, these are the ones that have physical quantities such as voltages, perform arithmetic and logical operations by measuring physical change in temperature or pressure. It measures values of continuous variable quantities. It is common in scientific work, so it's very common in scientific work. Digital computers, these are computers in which data is represented in digital or number form. Here, the computers operate on digital data by performing arithmetic